Major understandings about the difference between physical and chemical changes in properties are very important. So the first question we'll look at is question 32, which represents a chemical change. Chemical change involves the breaking and forming of bonds. And that means you should have a new substance. So the chemical change here is corrosion. So when you melt ice, you have solid water and liquid water. When you evaporate water, you have liquid water and water vapor. And crystallization is another word for solidification, which is another word for freezing. Question number 33 asks us to look at reference table H. Let's pull it up. So in question number 33, we're asked, what is the boiling point of ethanoic acid at 80 kilopascals? So 80 is given to us. That is a Y value. So we're going to go to the value of 80 and we're going to intersect with ethanoic acid. That's at approximately this line. So what we'll have to do is we want to know, well, what is X when Y is 80? And here, that's approximately 111. Don't forget to watch your scale. The x-axis, each tick is 5, while on the y-axis, each tick is 10. Now, question number 34 asks for a chemical property. Chemical properties describe how things react. So, iron reacting with oxygen to form rust describes how a reaction would take place. Now lastly, it asks what must happen for a chemical reaction to occur. This is referring to the collision theory, and the collision theory states that chemical reactions only occur if particles collide with sufficient energy and proper orientation, but the particles have to collide effectively. Now, please recall that the review sheet has answers at the end. In the interest of time, I am not going to review all of the practice problems. I will highlight the practice problems that I think will be most important for you to review. I will then place the high marks Chapter 6 multiple choice questions for your review. Good luck. Practice problem number 6 will be very important for you to review. Please review questions 7, 9, 10, 13, 14. Question 15, question 20, 21, 22. It is also important that you take a good amount of time practicing calculating concentration. In addition to parts per million and percent composition, molarity will be heavily examined on this exam. At the end of this, I'll place 2 more example problems of how to solve molarity concentration questions. So here's a sample molarity question that involves both the molarity formula and the moles formula. Here they ask how many grams of calcium chloride are in 1 liter sample of a 0.5 molar solution. So to solve this, we're first going to use the molarity equation. The molarity equation says molarity is equal to moles over liters. So plugging in the information from the question, we are given that we have a molarity of 0.5, and we're given that we have 1 liter. So our moles here, if we solved, now we can solve using cross multiplication. So now we have the number of moles of calcium chloride, but that was not the question. They want to know how many grams. So we're going to have to use the mole equation, where moles is the given mass over the gram formula mass. Recall that the gram formula mass can always be calculated using the formula and your periodic table. To find the gram formula mass of calcium chloride, we'll find the gram formula mass of calcium, 40.1, and chlorine, 35.5. Now, since calcium chloride has 2 chlorines, we have to multiply that by 2. So there's a gram formula mass of 111.1. So we know that we have a half a mole. We're looking for the grams. We have a gram formula mass of 111.1. Again, we can solve via cross multiplication. So our final answer is 55.6. This next example, again, we're going to have to use both the molarity equation and the moles equation. So recall that molarity is equal to moles over liters, and moles is equal to the given mass over the gram formula mass. So when we begin with our molarity equation here, we are looking for the molarity, but the only information we have is that we have 2.75 liters. So there's no way to solve. So now we're going to have to go over to the moles equation. In the moles equation, we know that we were given 60 grams of sodium hydroxide. Now, from here, we can calculate the gram formula mass of sodium hydroxide, which is 40. So from this calculation, we know that we have 1.5 moles. So we can take this number and plug it into our molarity equation to get our final answer.